In this lecture, I'd like to follow up on the last lecture on working with external data files, and I'd like to look at a particular special case called CSV files, or comma-separated values files. These are very, very common. I would be very surprised if you never downloaded any data that wasn't in a CSV file. And if you have any kind of Python career at all, I would be very surprised if you never built any CSV files. The most common place to get a CSV file is out of a spreadsheet. And if we export data as a plain text format, one of the options in any spreadsheet app is always going to be a CSV format. So here, for example, I've got a screenshot from a spreadsheet. These are, this is a Parenthood data set. You probably have seen this before. We've talked about it before. And if you've done any data viz work with me, you've seen this. It's one of my favorite data viz data sets. These are the ages of parenthood for various women. I have a corresponding file, the ages of parenthood for men. So what this tells me is here in 1565, there was a woman who had a child baptized, and the mother was 25.2 years old. And this is what this thing looks like as a spreadsheet. Now, in spreadsheets, there are all kinds of things. Like you can see that we've got the header, but there's some gray fill in the cells. That column 0 under year is all bold-faced font. So the spreadsheet has tons of formatting data in there that we will lose when we export it to a CSV, which would look like this. So you can see that there's a row at the top that has year and age. Those are the two metadata column headers, but all of the rest are just comma-separated values. And you'll notice that there are no spaces here, and the two columns are just separated by a comma. Now, if you think back, way back to the beginning of the term, when we started to talk about data structures, I said that there would be, at some point, some more complex data structures, and we looked at these a little bit. The spreadsheet lends itself to a complex data structure of a kind of a list of dictionaries. We talked about that a little bit earlier. So this is the kind of thing that I need to build today. This is the kind of thing that I build really commonly coming out of a CSV file. So as we go through, we're going to see how to work with all of those various parts. But when I started to think about it, I have a couple issues. I do have a couple of issues that I need to deal with. The first thing you might think is that, well, it's only a comma that separates these things. So I can do this by myself, and all I need to do is read in a line like I would read in from a normal external data file. That comes in as a string, and then I just split that. And we've seen before, we've used split to split on spaces, and in fact, if I don't tell split how to split, it will split on a space. Here, I'm just telling you to split on a comma. And so I could do this. So I have a particular line, and I want to split it on the comma, and then you'll notice I get a list of two elements. It seems legit, and for now, that would work. Here's one little bit of a dilemma, though. Because my data comes in as a string, each line is a string, when I split it on the comma, I still have strings. So one of the things we'll see before we're done today is converting those strings back into numbers. Well, that's only one issue that I have. Here's the other one. There's a header here. So the header is metadata. It isn't really data that I need. It describes what else occurs in that spreadsheet. So that 0th column is going to be a year, and the 1st column there is going to be an age. But that header comes across in my CSV file as just an ordinary row. And in fact, CSV has no way to determine what is a header and what is a legitimate row. So according to CSV, everything is a legitimate row. So if I want to handle that, and usually I do, I need to figure out how I want to do it. Now I've got a couple of choices, and we're going to see both of them today. So one is, maybe I choose to skip that row. I can do that. The second thing is, maybe I want to extract that row of headers and use it to build a dictionary. I can do that too. And in fact, Python has a really nifty way to do that. I can do it by hand, or I could let Python do it. And we'll see both of those going forward. Here's the third part of my dilemma. Now, I know this is a bit concocted, but I want to show you that the rules of CSV are actually way harder than you would think. So here is a pretend fake spreadsheet that I've built. I just have a column called page and some text that I've extracted. Now, one of the things you'll notice in the text in both of these rows is that the text contains commas. So if we take this top row here, this is page 5, if I just put that into a plain text CSV file, the CSV would say, well, there's our 2 columns. So don't say hello would be 1 column. There's a comma that separates the 2 columns, and he said is another column. In this case, you don't need to know this. We would call the comma a field separator, but that's okay. Now, we've got the same problem then in the next row here on page 8. There are actually 2 commas in there. So if I were just reading this as a plain CSV, that would turn into 3 different columns. Well, this is obviously not what I want. So what CSV says, this is the rule of CSV, is if my data contains a comma, put that data inside quotation marks. So that comma is solved by wrapping that whole line, that whole cell, inside quotation marks. The same thing for both of those. So far, so good. But you'll notice where I'm going next. Don't say hello begins with a quotation mark. But that's the thing that's supposed to separate or combine all of these parts if there's a comma in there. So that quotation mark also has, especially that cell also has a quotation mark, and that means, yeah, we get even more quotes out of that. So this data is really complicated, and the rules for CSV get crazy. And I'm going to show you, just for funsies, what this turns into, which is this, right? So you can see that don't say hello begins with a quotation mark. So what we do is we put a quotation mark outside of that. Now, in the last lecture series, we saw that Python can escape meta characters. CSV made a different decision. They said, no, we're not going to escape meta characters. In fact, what we will do is we will double the character. So if I wrap don't say hello, he said, inside quotation marks, don't say hello has a double quote and it gets doubled. And you can see what that is down here. So that data cell starts with a triple quotation mark, which is a little bit wonky. But now look at the next line. This abominable monstrosity is legitimate CSV, right? So they said they'd go soon, ends with a double quote, single quote, double quote. But we double all of those, so you get this monstrosity of 5 quotation marks down here just to handle the data, plus a 6th one after the exclamation point to wrap the whole cell and turn it into 1 unit. So what is the lesson to be learned here? The lesson to be learned here is don't do this on your own. Every language worth its salt has a library to handle CSV data. So does Python. And in Python, that library is called, believe it or not, CSV. Now, I know we haven't talked about modules yet, and we will very soon, I promise. CSV is a library of data that includes all of the knowledge about how to read and write CSV files. And even though it's a part of standard Python, that is to say, if you have installed Python, you already have the CSV library or the CSV module. But because Python runs lean and mean, Python says, hey, you know what? I'm just making a guess here. My guess is you don't need CSV files today. So I'm not going to load them. However, today, we do need CSV files. So at the top, I'm going to say, and I can do this on the command line too in the interpretive shell, import the CSV library. And that should not give you an error because, like I said, every Python standard installation has the CSV library, so you should be fine. Now, inside, what we can do inside the CSV library is what we can do is build either a reader or a writer. That reader and writer know all the complex rules about CSV files. So everything all that mess we were just looking at would not faze the reader and the writer here in any way, shape, or form. They understand all of those rules. What I do when I build either a reader or a writer is that I hand off to it a standard ordinary file object of exactly the type we were creating in the last lecture with open. And you can see that here down at the bottom. So this is my standard with block, and I'm going to open this file called women.csv, and I'm going to alias that as file. Now, again, that's just a random word. I could alias it as banana, and that would be okay too. But what I do is I take that object and I hand it off to the CSV reader. And then I take that and I put that into a new variable. CSV reader as a variable is an iterator just like any other file iterator. So you can see that I can put it into a for loop, I can put it into my comprehension, but what CSV reader does is automatically break down that row according to the commas. So if I had 2 columns in my CSV row, I'd get 2 elements out the back. If I had 9, I'd have 9. If I had some weird monstrous atrocity with 6 quotation marks on it, CSV reader would be able to handle that too. I wouldn't have any problems at all. Everything would be just fine. Now the headers, I can do the headers in a number of ways, and we'll play with this in the terminal here in just a minute. The first thing I could do though, if I knew what those columns were and I didn't particularly care for the headers at all, I could just skip them. I could get rid of them entirely. The cool thing about file or CSV reader being iterators is that every iterator knows how to go get the next thing. So when I create a new CSV reader, it's looking automatically at row 0. Remember, we could say that every row begins with 0 counting in Python. So CSV reader is automatically looking at row 0. But what I'm doing here in the blue text is I'm saying, take the row that you're pointing to and stick that into a new variable called header and then advance to the next row. So really what I'm doing there in that blue text is I'm just pulling off the header, and then you'll notice I'm just using a normal comprehension as I normally would. That's a really easy way just to get rid of the header. Now, could I use header? Yeah, I can use those. We'll see this in a minute. The second way that I could do it is that the CSV library has a different kind of reader in it, which is called a dict reader, right? Short for dictionary reader. Same thing. I handle it a traditional file object that I've built with open, but what the dict reader does is it makes an assumption that that 0th row is a header, and now it will use that to build a dictionary. And we'll see that as we go forward too. But first, let's try to build it ourselves so that we kind of understand what's happening. And actually, I'm going to come back and I'm going to work with that problem about string the numbers here too. So let's look at our code here. I'm just going to open this file, women.csv. I'm aliasing that object into a new variable called file. And then I'm going to hand file to a CSV reader. And now what I'm going to do is I'm going to pull off the headers. So I'm just going to say that the header is the next row that the CSV reader is pointing to. That is to say, I'm going to pull off row 0, and then CSV reader will start to look at row 1. And header itself is a little tiny list. So what is in header 0th element, it will be year, because that is the 0th column. And what is in header 1th will be the column called age. So I'll get year and age in there. So now we can see what I'm doing here in my comprehension. And I know this comprehension looks a little bit monstrous, but I think it's going to be okay, right? I've color-coded it a little bit. So you'll see what I'm doing is I'm building a dictionary, and I've got my curly braces there on the outside. Now I've color-coded it on the inside. I've got two key value pairs. The first key is header 0. That's going to be year. And then I'm adding element 0 as the value. Then I've got key 2, which is the 1th element in header, and another data value. Now you can see the problem down here. I've just shown you what those data values are. And we've seen that because that row comes in as a string, even if I split it, even if the CSV reader splits it, those elements are still strings, right? So I'm going to have 1568 as a string, but I'm also going to have 22.4 as a string. So what I'm going to do is I am going to cast the data types. The first one, 1568, is actually an integer. So I'm going to tell Python to cast that from a string into an integer. The second data value, 22.4, is a floating point number. Again, that's in opposition to a fixed point number. That terminology goes all the way back to the 1950s or earlier. But instead of a string of 22.4, I'm going to turn that into a floating point number of 22.4. So I'm building my own dictionary, and at the same time, I'm casting data from strings into numbers. And so if I look at it, what I'm going to get is this. A little tiny dictionary, the key value pair year, and then an integer 1568, and then age is the key 22.4. A floating point number is the value. And yay, those are numbers. We'll do this in just a minute. So just to repeat, here's a little screenshot again of that complex data structure that I was working with. If I want to do this with a dict reader or a dictionary reader, it is not much more significantly, it's not significantly harder. All I do now is, instead of saying I want to create a CSV reader, I create a dict reader. And all I do is read that data in exactly the same way I would before, except dict reader builds a dictionary for me automatically. And so what I can do is I can extract row 1, and I can extract the element called year, and I'll just get 1568 back. Now, two things about this. Number one, you'll notice that's still a string. So dict reader doesn't do any typecasting for me. If I want to do that, I'm going to have to do it by hand. If I was using a dict reader, I would probably just cast those back to numbers when I need to use them. Dict reader is so easy to read data in that I'm probably not going to make the trade-off of making it any more complicated trying to get data in. The second thing, and I won't really go into this very much today, is that dict reader doesn't really create a simple dictionary. It creates a more sophisticated data type called an ordered dictionary. So if you look at what we get in dict reader, maybe we'll do this in the terminal window here in just a minute, the data structure looks a little bit more complicated, but I can still access it the same way as I'm doing here. I can look in rows, with the 1th element in the drawer called year, and I can extract some data. All right, so let's move over to the terminal window, and we'll just play with this a little bit. All right, in the terminal window here, I'm just going to do a quick directory listing and make sure that I can see my files. There they are, min.csv, wmin.csv. Those are the two we'll play with today. Again, these are available on eClass. You can download them. They'll come as a zipped package. But just like we did last time, unzip that, put these files somewhere where you can access them. Do a change directory on your terminal window in case you need to get to that place. And I'm going to go into Python now. And because CSV is a module that is loaded with standard Python, but it doesn't import it every day, the first thing I need to do is to import CSV. And you'll notice, because I did not get an error message, no news is good news. So that means that it imported properly. Now, the first thing that I need to do is I need to open one of these files. And so I'm going to open women.csv. I alias that file object as my file. And then I need to build a CSV reader. And the CSV reader is in the CSV module, and it's just called reader, and I hand to it a traditional file object, which is my file. And now what I can do is I can collect all of those rows, and I'm just going to say it's row for row in CSV reader. Oh my gosh, I'm having a hard time right here. So let's just slice a little bit of that. Let's just get like 4 of those. And you can see what happens. This is a list of lists, but you can see that the year and the age as headers are treated just like any other row in that CSV file. So if I want to get rid of those, I've got a couple of options, right? The first thing is that I can call next. And so let's try that. I'm just going to hit the up arrow. I'm going to start over here. So I'm going to go back to with open, and I'm going to create my CSV reader right here. And now what I'm going to say is the headers are next CSV reader. Why it's really hard to type. And then now I'm going to come back and collect my rows. So I've got a block of 3 statements here. And now if I look at headers, there's my headers. And now if I look at rows 0, looking at the 0th element of rows, you can see that I get some data immediately. So that's one way that I can omit or skip that header. All right, let's build something with those headers, and let's do a little casting as well. I've taken the liberty of typing this out already, and so I'm just going to paste it right here into my terminal window. You can see what I'm doing, same thing. I'm opening that file, I'm aliasing it as my file, creating my CSV reader as I normally would. I am extracting the headers, and again, now if I look at headers or header 0, oh gosh, I can't type that. Header 0 is year, header 1 is age. So I'm using those right here as a way to build keys. Now the values is I'm taking a bit of data, the piece of data, and I'm converting the first one into an integer, and I'm converting that second one into a float. And I know this wraps around a little bit for every line in the CSV reader. Now here I've put this into a variable called data. So if I just slice off a little bit of data and I look at, say, first 5 elements, you can see what I get. It's a pretty simple way to think about it, or just pull one off. You can see that that is a dictionary. And so I can access year and age. So if I want to look at one of these, I can pull out data. Let's pull out data 45 and the year of that one, right, 1590. Or similarly the same one, age 38.2. So this creates a nice 2-dimensional data structure. It is a list of dictionaries, but everything has been cast properly, so I can start to work with those numbers for calculating, averages or max or mins, or do data viz, or do all of that sort of stuff. All right, one last thing here before we go. Let's do this with an ordered dict. So you'll see what I've done again here. I've imported CSV at the top. I'm opening women.csv as a file, but now I'm handing that to a dict reader, and I'm just creating a series of rows. So if I slice rows and get maybe the first 6, you can see that this is a little bit more complicated. It's still a list, but now this is an ordered dictionary, and I can see all of my elements in here. If I look at rows 1, you can see it's an ordered dictionary of 2 tuples, year and age. But I can access this in exactly the same way that I was just a second ago. I can ask what rows 1 drawer year is, and I get 1568. And the same thing, I can actually look what my age is capitalized, and so I get 22.4 there. So I can access this in exactly the same way I would in kind of a more traditional 2-dimensional data structure. But again, it's order to dict does not cast those automatically coming in. So if I wanted to do that now, I would do the same thing. I would just have to cast that now. If I wanted to, age is going to be, what is age afloat? So I can do that if I want to, and I can cast that properly if I need to. All right, well, that's it for CSV files. I know that maybe got a little bit longer than I wanted to today, but CSV files are a little more complex than you might assume right out of the gate. And hopefully this will help you go through this. You can use this as a reference for working with CSV files in the future, or if you're building your own, to work with CSV writers as well. All right, thanks.